Hey, curious people. This is my second time recording this because I recorded it the wrong way again. But because I'm in such a hopeful mood today, I'm going to help you out with your salt issues. Because if you clicked on this video, I'm assuming your salt is exploding, right? Because if not, then there's no point of clicking on the video. Kidding, of course. All engagement is good engagement. But this is mainly for the people with the salt issues. So, are you having issues when you mix your salt with water? And by issues, I mean like explosions, not just like normal issues, like stuff that shouldn't be happening. Well, I'm here to let you know that help has arrived. Salvation is here on a white horse. And I am the guy on the horse. So let's look at why this could be happening. Well, as you can see, because the camera has panned down here multiple times, sodium is an alkaline metal. And as we know, the alkaline metals do not react nicely with H2O. They don't really like each other. And so because of that, alkaline metals kind of, light up or ignite whenever they touch water. It's not a friendly interaction. So anyways, salt is sodium and chlorine mixed together in an ionic bond. Remember, ionization. And remember, when they ionize, sodium becomes a positive ion, and chlorine or chloride becomes a negative ion. And when this happens, they both end up happy because they both have full shells, fulfilling the octet rule. And because they have full shells, they are similar to noble gases, which also have full shells. But the difference between them and the noble gases is the noble gases have full shells from birth, while they just gain full shells. So noble gases, because they have full shells and they're like all preppy and stuff, they don't need to bond with other people's electrons, because why would you? You already have a full shell. So, what does this have to do with these guys again? I kind of already told you, but let's just re-go over it. So yeah, anyways, they don't like to bond. And because this is all from the last time I recorded the video, but because sodium and chlorine are functioning this way, like noble gases, they also aren't going to bond because they have full octets. And I wrote this up here because this was like chlorine. Chlorine originally has 3 shells, but when it ionizes, it loses the valence electron on the 3rd shell and now only has 2 shells. And on the 2nd one, there are 8 valence electrons, meaning it has a full octet like a noble gas, and so it doesn't bond. So when you dissolve salt into water, the sodium and chlorine ions break apart and get surrounded in these things called spheres of hydration. The sodium, because it's a positive ion, gets surrounded by the partially negative oxygen molecules, and the chlorine or chloride, because it's a negative ion, gets surrounded by the positive hydrogen, the partially positive hydrogens in the H2O polar molecule. So, because it's a sodium ion and not just sodium, it won't react with the water because remember the full octets, and therefore it won't explode like normal sodium would. So, this is why your salt isn't supposed to explode in water. That's not normal. So, let's look into what might have happened. Someone may have stolen your salt and replaced it with sodium, which is that's not a good thing. So my tip to you would be to get new salt as soon as possible, and also go see your doctor as soon as possible, because you're not supposed to be ingesting sodium. At least I don't think so. It might not be good for the body. But you know what they say, 1 sodium a day keeps the doctors away. They don't say that. Please don't use sodium. Anyways, I hope this helped you with your salt problems. And if you have any more issues, don't leave them to me. I'm not that helpful. So, yeah. Don't eat sodium is the moral of the story.